Now that we've got a handle on all the basic operations for lists, let's take a look at some additional operations that are available on lists in Python. Starting with list concatenation. So we've already seen concatenation for strings. This is the exact same thing, but with two different lists. This takes two lists and joins them, and the result being those two lists effectively run together. It's important to note that the inputs for this operation need to both be lists in order for it to work, just like when we were concatenating strings, they had to both be strings in order for it to work. Returning to Python, we could say, for example, if names is a list with these names in it, then we could concatenate or plus equals a list with more names in it. So let's say Alan and Frodo. And now our list has changed to extend more values. All right, it just takes those two lists and puts them together. I could take two separate list variables, so x is 1, 2, 3, and y is 4, 5, 6. And I could just say x plus y, and that's the list with all those values together. Returning to our previous example, we saw we couldn't solve this using a for each loop because we didn't have access to the index to store the result back in our list. But one way we could do this is just to store these results in a new list. So we could square each item and then attach that to the end of a new list. So let's say def square list 2 that starts with some empty list. We'll call it result is some empty list. And then for each item in that list, we're just going to square it and add it to that result. So we'll say for Ellie in list. So a for each loop going through each item, and Ellie is now this copy of that value. We're going to say take the value of result and concatenate on this new list. So I would say, in this case, Ellie times Ellie. But notice I have to wrap these in square brackets. If I just said Ellie times Ellie, it's going to try and concatenate a list and a number, and just like trying to do that with a string and a number, there's a type error involved there. So this says create just the square of the number. Putting square brackets around it says create a list that contains that square of a number, so it's a list with one element, and then we're concatenating that onto the result. When we're done, we return the result, and we can see our outputs. So let's just change this to square list 2 and save our code. So if I said python list.py, we get the same output, 14916. Let's put another number in here just to make sure things are working as expected. And we get 14916 and 25. So that's list concatenation, which can be quite useful to extend existing lists. There's also a list multiplication, which is somewhat less useful. Again, this is Python only, but just like strings, we can take an existing list and multiply it, and it creates just copies of that list. So returning to Python, if I have a list called x that's 1, 2, 3, I could say y equals x times 3, and then y just has that list repeated multiple times. This is sometimes helpful for initializing a list with a bunch of base values. So for example, if I wanted a list with 100 zeros, I could say zeros equals, and then just start typing 0, 0, 0, and make sure I get 100 of those, which I'm almost certainly going to make a typo. Alternatively, I could just say it's the list with 1 0 times 100. And now I have 100 zeros. And I know it's 100 zeros because I used just the digit 100 to represent how many times it would do it, rather than having to manually type it 100 times. So that's list multiplication. And one more useful Python operation is list membership. So that's the keyword in. So we've already seen this keyword used inside for loops, where we say for I in range. I mentioned at the time that the in keyword is overloaded. It has multiple meanings. So as part of a for loop, it helps extract values from our range into our loop variable. But when we're just using it outside of a for loop, it's asking a question. It's almost a comparison, but it's a comparison for lists. In this case, it's asking, is the item somewhere in this list? So walk through each item in the list and check if it's there. We could do this manually, but Python has this built in. So 3 in the list 1, 2, 3, 4 returns true because there is a 3 in there. 5 not in the list 1, 2, 3, 4, also true because there isn't a 5 in there. So if you want to check for non-membership as well as membership, both are options. So back in Python, if I have this list of names, I can ask, is Bob in names? And that's true. I could ask, is Gandalf in names? And that's false. So this is useful, for example, if I want to make sure there's only one value of an item in a list, I can say something like, if Gandalf not in names, then names plus equals, and we can concatenate Gandalf to the end of that. Right, and if I ran that twice, get my other command back, there it is. It didn't add it twice because the check says if it's not in there, then add it. If it is, then don't. And the last major operation for lists in Python is what's known as list slices, or list slicing. The purpose here is to make a sublist out of an original list. So the syntax for creating a sublist is the name of our list with square brackets afterward, as though we were going to access a single element, but instead of including a single index, we'll include two indexes with a colon between them. So list, the start index, colon, the end index. And this will return a list that contains all of the values between those indices. Again, notice the start index is inclusive and the end index is exclusive. So if we say from the range 2 to 4, that means include 2, but don't include 4. So this would just be the list from 2 to 3. So 0, 1, 2, 3, 4. We get 2 and 3, which is just these two items. There's some shorthands for using this. If we want to start at the beginning of a list, we can leave off the start index. If we want to end at the end of our list, we can omit the last index. If we omit both, we get a copy of the entire list. Returning to VS Code, if this is our list of names, we could then say names from 1 to 4, and that returns names at index 1, 2, and 3 as its own new list. So Bob, Charlie, and Dean, but notice the list itself is unchanged, so this creates a copy of that list. I could also use negative indexes, so I could say names from 1 to -2. We get Bob, Charlie because our range starts at 1, which is 0, 1, and it ends up to, but not including -2. So -1, -2, so we omit these, so our range is just these two here. And as we saw, we could say names from the beginning up to, let's say, 3, and that's just the first 3 items. We could say names from 3 up to the end, and that's the last 2. So 0, 1, 2, 3, and then up to the end. Next, to practice that we understood all of this, let's full screen our terminal and just do a quick comprehension demo. So I'll say create a new list called L that has the values 5, 8, 2, 1, and 4. So if I ask what's the value of our list, 5, 8, 2, 1, 4. Now if I said L at 3, what would be the output? I recommend keeping your finger over the pause button here because I'm going to go through many of these such steps. Try to figure out what the output would be and then see what the output actually is. So if I say L at 3, we get the third element. So 0, 1, 2, 3 is the value 1. If I say L at 4 equals L at 2 plus L at 3, then what's the value of L? So in this case, we took the values of L at 2 and L at 3 and added them together. So if L is still here, so 0, 1, 2 is 2, and 3 is 1, so 2 plus 1 gives us 3, and we store that at L4, so 0, 1, 2, 3, 4. So this last 4 should have turned to a 3. Everything else should be the same. Okay, I can ask what's the len of L? We should be able to see pretty easily, that's a 5. I could say L plus, and then the list 7, 9. So that gives us a list that has 2 extra values. But then if I ask what's the value of L, it's unchanged because we didn't assign that change back into the original variable. We could say L equals L plus 7, 9. And now that change is stuck. We could ask, is 6 in L? Looking through the current values of L, that should be false. We could also say L equals L plus, and then the list 6 in L. Bit of a weird statement. That's fine. But now if I ask what's the value of L, what would the value be? Well, we've seen the value of 6 in L is the word false. So if we take the value of L, we concatenate on the list that has the word false in it, so that's just a list with one element that is false. Then we'll have the original list plus the word false. So it's going to be this list, and then one more element that is false. I could take a slice from L at 0 up to the len of L. And what would that slice be? Here we're starting at the beginning, we're ending at the end. Remember, the end index is exclusive, so that's a valid end index. That just means go right to the end of our list. And that gives us the entire list. If I said L from the beginning to the len of L minus 3, then what would that be? Noting that L hasn't changed. So that's the beginning. If we go minus 3, so that's minus 1, minus 2, minus 3. So that's minus 3. So it's going to be all of this. What's the value of L? L still hasn't changed because we haven't assigned any of these changes. If I asked what's the value of L between 5 and 7, what will that slice be? In this case, we go to index 5, 0, 1, 2, 3, 4, 5, and then 6 and 7. So we don't include 7, so it's just 5 and 6. So we get 7 and 9. Index is 5 and 6, values 7 and 9. I could also ask, is 2 in L the slice of L from the beginning up to 2? Now, would this be true or false? So the indexes from 0 to 2, so that's indexes 0 and 1, is 5 and 8. There's no 2 in that, so this should be false. And we get false. All right, so that's list operations. We saw slices and concatenation, which are used somewhat often. We also saw multiplication, which is a little bit less useful. We also saw membership, which is also quite useful, but can be overused, as we'll see in a later chapter.